We are the Semi-Autonomous Rescue Team, or S.A.R.T, from St. Francis Xavier College in Canberra, Australia. Our school is made up of students from 13 to 18 years of age, and this is our 2021 robot, Bender, a simple yet effective robot that is really focused on our learning and on new design ideologies for our team.
Our team first formed in early 2015 with the goal of producing a small, cheap and easy to manufacture rescue robot for first responders in emergency situations. We have since competed at a number of RoboCup competitions, with our team evolving and changing through the years as previous members graduated and new members joined.
Our primary goal is to make the competition, our learning and our developments as accessible as possible. We achieve this through our website, which presents information about our team, our robot and our achievements, as well as providing a regular blog of our progress and learning for new existing teams to follow.
The Rapidly Manufactured Rescue Challenge, or RMRC, is a competition designed to bridge the gap between RoboCup Junior Line and Maze Rescue competitions for primary and secondary students, and the Major Rescue Competition for universities.
Robots competing in RMRC are tested in a number of standard testing methods developed by NIST, the National Institute of Standards and Testing. These test methods help to evaluate the robot's capabilities in managing diverse and difficult terrain through 5-minute runs which identify how successful a robot is at navigating each terrain type.
Robots are also tested on how well they can gather information about the environment for emergency services personnel, using a suite of sensors and to identify hazmat signs, QR codes, heat sources, etc.
Teams who are successful in these tests progress to the finals, where their robot is put to the test in a 15-minute run of an arena, made up of all the testing methods and adding extra difficulties such as ramps and drops.
Robots are designed to be semi-autonomous. This is how they can both run by a teleoperator from a remote control location, either through wireless communication or a physical tether, or can operate autonomously using sensors and software to identify and navigate terrain.
As well as optical cameras for vision while the robot is exploring new terrain, robots are often also equipped with other sensors, such as temperature sensors or thermal cameras to identify heat sources and locate victims. Two-way audio communication through a speaker and microphone to communicate with victims, CO2 and volatile gas sensors to detect victims and identify hazard gases for emergency personnel, as well as distance sensors to help robots map their environment.
Over the years, S.A.R.T has tested and explored a number of different robot configurations, software and technologies to enhance our robot's functionality. Our project is broken up into 3 categories: robot, software, control panel.
Our robots have used both wheeled and tracked configurations, with both having benefits and drawbacks depending on the testing environments and applications. For this year's virtual competition, our major change to our robot has been the use of DC motors instead of dynamics or servo motors. DC motors are more affordable, more robust, and more reliable, and so we have gone back to basics this year to experiment with this alternative technology and everything associated with it.
As S.A.R.T, we are very proud of the software package we have developed to run our robots, S.A.R.T. S.A.R.T is a one-stop shop for teams building robots for RMRC, with a custom-built user interface and lots of back-end features, supporting a range of motors and motor controllers, as well as sensors which can all display on the control panel.
Our control panel is another major highlight of our team. This year, powered by Dell Technologies, our control panel is a clean and sophisticated design which offers users everything they need to operate any of our robots remotely. The control panel boasts 45 to 60 minutes of wireless operation using the included backup battery, a built-in industry standard wireless access point for setting up its own communication network with our robots, and a rugged design which can be taken anywhere.
This year, we've implemented 2 key innovations to our project, which we think would greatly assist other teams in their own robots for RMRC. These innovations are in the areas of power and mapping.
Power is an area that always challenges teams. Delivering reliable power in a safe and effective way can be challenging. Most teams opt to use LiPo batteries, which are certainly effective power methods, but suffer from poor safety and issues running
we explored a number of possible alternatives until we discovered an industry standard solution: power tool batteries. Power tool batteries offer the same power characteristics as LiPo batteries, but are much safer in both operation and charging, and much more accessible.
But our most exciting innovation this year is the Z Mini camera. This RGB-D camera is designed for use with virtual reality headsets, but certainly suits our applications. With SDK support for our NVIDIA Jetson Nano, and offers the ability to fully map a 3D environment with textures. This means that our operator can drive around a space using the same camera that is also creating a three-dimensional spatial map of our environment, allowing the operator to share that environment in full color and high detail to anyone else.
Our future plans are to implement SLAM, or simultaneous localization and mapping, with the camera to drastically improve our robot's automation functionality over alternative designs we have tested that require top-mounted spinning LiDARs to work. We can't wait to see the possibilities the camera opens up for us and other teams.
For new teams or teams just getting started, we want to do everything we can to do to help. Our blog, available through our website, is a great place to start. It has tutorials, guides, hints, tips, and tricks that we have learned through our 6 years in this competition.
This year we want to do something extra to help the new and existing teams back into the RMRC after the impacts of COVID-19. We've been developing a new S.A.R.T junior robot, complete with files for manufacture with both laser cutting or 3D printing options available, a how-to guide for assembling the robot, and a complete software package to get the team started.
While the robot platform is simple, using basic DC motors, a Raspberry Pi, and single front-facing PiCam, it is a great place for teams to start and develop their skills for RMRC. We are really proud of this development and hope to add more basic designs and tutorials for new and existing teams to try in the coming months.
We can't wait to meet you all next year when RoboCup International can meet again. Until then, good luck with your robots, stay in touch on the forums so we can support each other's development, and keep an eye out on our blog and social media channels for news and future development for S.A.R.T.
Thanks for watching.